So today we are going to be looking at lesson 112. And our essential question for today is what order must operations be evaluated to solve, to find a solution when there are parentheses within another set of parentheses, right? So that's the big thing here. When we have multiple sets of parentheses, how do we work our way through it? We are going to start off by looking at a story problem or two and writing numerical expressions to go with them, and also figuring out how do we need to go about evaluating. So here it says that Mary's weekly allowance is $8 and David's weekly allowance is $5. Every week they each spend $2 on lunch. Write a numerical expression to show how many weeks, right? So that's a big part of this, how many weeks it will take them together to save enough money to buy a video game for $45. And let's make our little writer a little bit smaller. So my big question is how many weeks will it take them to save the money up to save $45? Well, as I work backwards through this, I know that they're saving their money together, right? So that's an important piece. And I know that they don't quite get the same amount of money, but they spend about the same amount each week. So I'm going to work through this and I'm going to think to myself, first of all, how much money does Mary save? And I want to write that down in a set of parentheses, right? So the Mary's weekly allowance is $8, but she spends $2 on lunch, right? So if we spend it, that is money that is subtracted. So this is Mary's money, right? We also know that David gets some money each week as well. So we're going to put together a set of parentheses for David because David gets $5 each week and spends $2 on lunch. Right? So this set of parentheses on the left is for Mary. The set on the right is for David. Now, if I want to put their money together, that means that I need to put an addition symbol in between the two. So I have Mary's money added to David's money. Now, on top of all of this, right, they want to save up money to buy a video game for $45. So somehow I have to show that these two sets of parentheses go together before I do anything else. And the way that I do that is by using a set of brackets, right? And all that the brackets mean is that everything inside of the brackets has to be done first. They're like kind of a bigger set of parentheses. So, right, so I need to show that down here, and I need a little bit more room, so I'm going to rewrite this, right? So I have Mary's money is 8 minus 2. I have to add that to David's money, which is 5 minus 2, and then I need to close my set of brackets. Now, if they are saving up for a $45 video game, and I want to know how many weeks it's going to take them, right? This set of brackets from here to here, this tells me that this is 1 week's saving, right? Remember, we identified that the parentheses were for Mary and for David. Together in the brackets, it's for the weeks that we saved up. And then we would do our division to finally solve this problem. So that's what our numerical expression is going to look like. Now, a lot of you would probably just do this by solving for Mary's money, solving for David's money, adding that together, and then divide 45 by it. And that's all we're going to do here. When we have parentheses inside of a set of brackets, we just solve the parentheses first, and then we solve for the brackets. It's kind of like peeling back the layers of an onion. We start at the inside, and then we need to work our way to the outside. So I guess it's a little different, but you get the idea. All right, let's take a look at another one, and we'll actually solve this one. So here we have John, and John gets $6 for his weekly allowance and spends $4 of it. His sister, Tina, gets $7 for her weekly allowance and spends $3 of it. Well, their mother's birthday is in 4 weeks. If they spend the same amount each week, how much money can they save together in that time? So we want to spend the same amount each week, right? So they're doing the same thing over and over again. They're going to be doing it together, right? So we know that we're going to need to figure out how much money they each get, and we're going to need to add that. So if we look over here, they've already written our expression for us. And so we have 4 times a set of brackets, and then inside of that we have 6 minus 4 in one set of parentheses added to 7 minus 3 in another set of parentheses. So I just want to go through and figure out, like, what do these numbers mean? Well, the 6 minus 4, right, that stands for the amount of money that John has at the end of a week, because it says here that he gets $6 and spends $4. So we have 6 minus 4. So this set of parentheses is for John. Now, that means that the other one is probably for Tina, but let's just double check. Tina gets $7 for her weekly allowance, and she spends 3 of it, right? So this set of parentheses is Tina's money. Now, when we add them together and we put them inside of these brackets, right, that means that that's 1 week that they save their money for. But they're not just going to save their money for 1 week, they're going to save their money for 4. So we need to multiply by that 4. Now, as we evaluate this, right, we know that our order of operation says parentheses, exponents, multiplication, division, addition, and subtraction. Well, parentheses can mean our traditional parentheses. It can mean brackets, or it can mean, that's a terrible set of braces, but braces. And when we have parentheses, brackets, and braces, we start on the inside with our parentheses, and then we move to the next level with our brackets. So let's start with our parentheses. 6 minus 4 means that each week John only saves $2. 7 minus 3 means that each week Tina saves $4. So we solved our parentheses first. Now that we've solved our parentheses, we need to solve our brackets. 2 plus 4 is 6. We're going to bring down our 4 we're multiplying by. And now, each week together, they save $6. They do this for 4 consecutive weeks. So we multiply 4 times 6 is $24. So at the end of 4 weeks, together, they have $24 that they can use to buy their mother's birthday gift. All right, we're going to look at this. Now here we can see that we see our normal parentheses, we see a set of brackets, and we see a set of braces, and they label those for us here. Now, when you're working on problems that are like this, and granted, these problems are relatively easy, right? We have basic facts like 5 minus 2, and we multiply by 3, and 2 plus 4, and they're all single digit numbers. So they're all pretty easy to keep straight. But what I don't like about how they set this problem up is that everything just keeps getting skinnier. And along the way, these problems are going to get harder. And so it's really important that we practice good organization as we work through this. So instead of everything getting skinnier, I am going to open this up on a new page, and I'm going to try to work everything in and work it straight down. So over here to the side, I'm going to write up my PMDAS, right? Please excuse my dear Aunt Sally. And I am going to start with my parentheses. Now, we're going to start with our standard parentheses first. We can solve these at the same time, right? Because they are both the same and they are not really connected. So I can solve for 5 minus 2, and I'm going to write directly below that that's 3. I can solve for 2 plus 4, and I'm going to write directly below that that is 6. Now, here's the thing that a lot of 5th graders don't like to do. You all don't like to do a little bit of extra work, but it's really going to pay off to make sure to rewrite the whole problem and keep the whole thing just in line. And the reason why I recommend doing that is because, again, like, if we make a mistake, it's going to be a lot easier to look straight back up and see where we made that mistake at. So now that we've gotten to this point, we've taken care of our standard parentheses. Now we can do our brackets. So we're going to look at this. We have 3 times 3 in this set of brackets. 6 times 2 in this set of brackets. Again, they're independent of one another, so we can solve them both together or at the same time. 3 times 3 is 9. 6 times 2 is 12. Now, again, I'm just going to bring everything down in order and rewrite it. So here's my addition symbol that's between those two sets of brackets. Here's my terrible set of braces that I draw, and the other set. And then, of course, out here on the outside, I'm going to write multiplying by 4. Now, we did parentheses. We've done our brackets. Now we are on the outside, right? We've taken care of everything on the inside. So now we can finally solve for our braces. 9 plus 12 is 21. Again, I just rewrite it like right in the middle. And then I have my multiplying by 4. And 4 times 21 tells me that my final answer is 4 times 1 is 4. 4 times 2 is 8. So this problem that is so large and big, right, really in the end doesn't give us a huge number. It just gives us the number 84. Like I said, I really think it's important that we keep all of this in order, right? Like the 2 times the 4 came together to make 6. The 5, I'm sorry, not 2 times 4, 2 plus 4. 5 minus 2 came together to equal 3. And then I just always rewrite it like directly underneath the middle of it. It just helps me if I ever make a mistake. Like say, for example, over here, I said that this wasn't 12. I got a little bit confused and I said that it was 8. Well, if I go back through and it's like this, it's easy for me to see where I made this mistake because I can go through and I can double check. I can say 5 minus 2 is 3. That's right. 2 plus 4 is 6. That's right. 3 times 3 is 9. That's right. 6 times 2. Oh, wait, that's not 8. That should have been 12. Right? And so then, I would be able to recognize that error. So that's going to be my pitch for that. Try to keep it in order. Rewrite each line because trust me, it just gets harder and harder when you get older. The numbers get bigger, they're more complicated, and it's going to really pay off. All right, let's try some of these. We're going to start with this one, which is not quite as big as that one. So go ahead and pause the video, try to solve it, and then come back and let's see how you did. All right, I'm going to start by writing my order of operations over here. I'm going to start with my parentheses. Remember, I start with my normal parentheses, and then I work my way out to brackets, and then if I have them, I do braces. So 17 plus 8 is 25. Rewrite that. Plus 29 minus 12, that leaves me with 17. I'm going to rewrite my braces so that I don't forget about them. Now I get 25 plus 17. 7 plus 5 is, what is that? That's 12. I regroup. 2 plus 1 is 4. So I get 42 divided by 16. And the answer to this one is 7. Let's try another one. Again, here we have not just parentheses, but we have brackets, and then we have braces. So you try to solve it after pausing the video and come back and see how you did. All right, so starting with my parentheses, I have 12 minus 8 in this set of parentheses, and that's 4. I have 11 minus 9, and that is 2. I'm going to rewrite things so I can keep it straight. Let's see, we close these brackets and braces, and then we multiply by 3. All right, next layer, 4 times 2 is 8. I'm going to add that 2 times, oh, looks like I forgot something, right? So I need to make sure I bring it down that 3. 2 times 3 is 6. So I've solved the brackets, and now all I'm left with is the braces. I finish inside of the braces. 8 plus 6 is 14. And 3 times 14, well, 3 times 4 is 12. 3 times 1 is 3 plus 1 is 4. And so the answer to this numerical expression is 42. So again, right, I skipped something as I rewrote it, but because I kept it in order, right, I could see here that it was this 3 that I had missed and was able to fill it back in. Last one for this day. Here we need to write an expression to show how many roses Dan sells in one day. It says Dan has a flower shop, and each day he displays 24 roses. He gives away 10 and sells the rest. Each day he displays 36 carnations. He gives away 12 and sells the rest. What expression can you use to find out how many roses and carnations Dan sells in a week? So, again, let's get our thin line. So here we are. We have Dan. He seems like a really nice guy, right? He's giving away flowers every day and selling some flowers every day. And we want to take a look at an expression to find out how many roses and carnation he sells in a week. So I'm going to say to myself that I know that I need to do something with roses. I know that I need to do something with carnations, right? And I know that he does this in a week, right? And it's talking about each day. So I need to know how many days he does this for. Well, the number of days is really easy. There are 7 days in a week. And if he does the same thing every day, then we're going to be multiplying. Now, for our roses, it says each day he displays 24 roses. So we display 24 and he gives away 10, right? Well, not worried about how many he gives away. I'm worried about how many he sells. So I need to figure that out by subtracting those 10 that he gives away from the 24 he displays. And whatever's left tells me how many he sells. We're going to do the same thing with carnations. Each day here, he displays 36 carnations and he gives away 12. So whatever the difference between those two are is what he actually sells. So let's see, we have our roses he sells each day. We have our carnations he sells each day. I want to know about both of them, so I'm going to add them together to make sure that I know that this is happening week by week. I'm going to group these two things together because I need to know how many roses and carnation he sells each day. And then I need to multiply that by 7 days to figure it out for the week. All right, let's solve this one. 24 minus 10 is 14. 36 minus 12 is 24. So I get 14 plus 24, which is 38. And I multiply this by 7. Well, 7 times 8 is 56. And 7 times 3 is 21, plus 5 is 26. So each week, Dan sells 266 carnations and roses combined. All right, if you need to go back and review part of this video to figure some of these out, you can do that. Try out the problems on the Think Central website. And as always, good luck.